Hello dear friends, today we will discuss the design procedure of V-belt. We will be discussing the design of conventional type, the classical V-belt, which is given there in your data handbook. Even though we have got different types of V-belt, we will be discussing only this basic design because that is common for all the belt drives. Okay, so moving into the design procedure. See, the initial two steps are same as that of the flat belt because you are supposed to calculate the all the values n, small n, capital D and small d using the velocity ratio equation. Okay, and step number 2 is the calculation of velocity. These two steps are self-explanatory, and in the question if they have not specified anything regarding the diameters, then you can use the table 14.16 to get the minimum diameter required. Okay, this is the table 14.16 which gives you the various values of pitch diameters for different cross sections and for alpha values. Okay, alpha is nothing but the groove angle or the belt angle. Okay, this angle is called as the alpha. Okay, that table can also be used in the step number 1, but generally we are not using that. All the data will be provided. If there is no other go, you can go for that particular table. Okay, now moving forward, we have to explain the step number 3 and step number 4 together. The reason because we are using the value of equivalent pitch diameter for selecting the cross section. Okay, because we have not specified any equation number because it is not specified there in the data handbook. So let us have a discussion along with the data handbook. Okay, kindly look here. See the table, there's a table given, but there is a not table number. Anyway, the equation is 14.13a to E. 14.13a to E deals with various cross sections. I think it is given over here, cross section A, B, C, D and E. Okay, various equations for calculating the power ratings, power capacities of the belt. Okay, so if you need to select this cross section, you should have the value of D. D is given here. D is nothing but small d into capital KD. The small d we have obtained in the table step number 1. Now we have to go for the KD. What is KD? KD is a small diameter factor given in the table number 14.15. Let us go to the table number 14.15 and see what is given over there. Okay, 14.15. See, this is the table 14.15. Here you have the first columns. The odd columns gives you the range of a value. So whatever might be the range under which your given velocity ratio comes, you select the corresponding KD value. It's very simple. There is nothing to worry about. Okay, so get the value of KD here, substitute back in this equation and get the value of D. Okay, now comes the selection, but how will you select? Okay, so kindly read the data given here. It is stating that maximum value of D in the formula. What is the meaning of that? Meaning is this: if D is less than or equal to 125, you can select the cross section A. If the value of D is less than 175 and greater than 125, that means if D is coming in between 125 to 175, you have to go for B. Similarly, based upon these values of D, you select the correct range and get the cross section. Okay, so once you have the cross section, you have the equation here. The variables that is used in the equation is small v, small d, all those things. We have obtained the v value in the step number 2 and d in the step number 3. So all values you have got, you can directly substitute it here and get the values of power rating in kilowatt. Okay, now comes the next step. Okay, next step is nothing but the calculation of number of belt. Okay, the equation is nothing but 14.14, page number 295 is given over here. This is the equation that we are going to use. Okay, so equation is PKS divided by KW into KL into A. I think it is very clear. Okay, what exactly is P? It is given here. P is the drive power. Whatever might be the power rating of the belt, what is the power which is required to be transmitted, or the power that is given in the question, that has to be substituted for P in kilowatts. Okay. Now we are supposed to find out the value of Ks, KL and Ka. Ks is obtained in table number 14.19, KL in the 14.20 and Ka in the 14.121. I will explain that right now. Okay. So what about the small kW? This small kW is nothing but the value of power that we have obtained in the step number 4. There is a chance that you will get confused with the data provided in the handbook, because in the handbook they have stated that kW is the rating of V-belt obtained from the table 14.18 or from the equation 14.13, but the problem is you are not only using this 14.13a, you can use any of these 5 equations. So whatever might be the value you obtained here has to be substituted for the small kW value here. Okay, now the question is, what is there in the table number 14.18? Let us go and have a look. 14.18, this is the table 14.18a. So we have got 5 different tables: 14.18a, we have got 14.18b, 18c, 18d and 18e, corresponds to cross section A, cross section B, cross section C, cross section D and cross section E. See, what does this table gives us? This gives us the power rating of the V-belt drive. This gives the power rating. So what is the, how will you select this? Suppose if you have a pitch diameter D 100 mm and if you have velocity ratio 10, you can get the value of power rating as 1.62. This will be exactly same as that of the value you calculated at the step number 4. Okay, but the problem for not using, or the problem associated with using this table is, see, you will not be having, or you may not be having a belt speed value in a wall number, or you may not be having a equivalent diameter D as 80, 90, 100. It can take up any values in between 80, 90, or in from 80 onwards it can take up any values. Okay, so if that is the case, definitely you have to go for some kind of interpolation. Okay, so if you are good at interpolation, you can avoid calculating this step number 4 and you can come here and directly select the value of kW. Else it is better to go for the equation 14.13a to E. Okay, so please don't get confused. In both these methods can be adopted for getting the value of kW. Now comes the selection of Ks, KL and K. These are lying in the subsequent tables 14.19, table 14.20 and 200. So on have a discussion on that. Okay, so this is the table number 14.19. I think it is clear. Okay, see, this 14.19 table deals with the various environmental conditions and the type of application under which this particular belt works. Okay, so you can see different conditions here: light duty, medium duty, heavy duty, extra heavy duty. Like that, you have got different sets of applications. Okay, so if you know the application, you can go and select which one is suiting to your application. If not, you have to assume everything in this table. That means, for example, I will go for an assumption like medium duty, okay, used for a generator, okay, or a press, like that. Then I will assume a type M or type N and I will choose a particular working hour. Suppose if these data are not provided, you have the freedom to select values from this. Okay, so please don't worry, because based upon person to person this assumption is going to change and thereby the answer is also going to change. Okay, so you kindly go for a suitable assumption and get the values for Ks. Now comes the calculation of KL. Okay, KL is not calculated, is being selected from this particular table 14.20. Now the question is, what exactly is the value of KL, or how will you be select the value of KL? See, this KL can be obtained from the table number 14.20 based upon the values of nominal inside length. Okay, so the next step is nothing but what? The calculation of length. Okay, for that you can use the equation 14.15b. So 14.15b is here, L equal to 2c plus 1.57d plus d minus d all square by 4c. So you can use this equation 14.15b for the calculation of L. Okay, so L can be easily obtained Okay, based upon the value of n, you can get the value of KL from this table. I think it's very easy for you to calculate. Okay, if the value is coming in between these the values which is given, you need to go for interpolating the values, okay, and get the value for KL. Now next portion is the calculation of KA. K is the correction factor for the arc of contact. So if you want to, so we have to calculate the arc of contact. So how will we calculate the arc of contact? See, we don't have a special equation for calculating the arc of contact for the V belt. We have to utilize the equations for the given for the flat belt, calculate the arc of contact for the V belt also. So that is the equation number 14.1a and 14.1b. Okay, 14.1a and 14.1b gives you the theta for the smaller pulley and the lateral pulley. So you can use any of those two equations and to get the values of KA. So VV configuration or V flat configuration. Generally we are going for VV configuration because usually V belt in a V groove. That is the usual assumption that we have. So so we will be going for VV configuration and we will corresponding to the value of arc of contact in we are going to get the values of VV. See, one thing you have to keep in mind that, see, this column gives you the value of arc of contact in degree. See, it has to be very, very clear. Okay, and the equation, from the equation 14.1a and 14.1b, the value you are going to get in radians. So you have to multiply the value that is obtained in the equation 14.1a and 14.1b with the 180 by pi. So please make a note of that. You multiply the value obtained in radians with the 180 by pi and convert it into degree and use that particular degree to get the value of K. Okay, so now we will we have all the values, so we can calculate the n dash. N dash is nothing but the number of belt required to transmit the given power. Okay, so usually by this we are going to conclude the design of V belt, but there are some other cases also which you should know. Suppose if they have not specified anything regarding the belt, or if they have given you the cross sectional area or the cross sections, then you can choose the equation 14.16a also. This equation 14.16a. 14.16a is nothing but n dash AB by 1000 sigma d and the remaining portion. Okay, see what is n dash? N dash is same as that of the number of belt required. A is the cross sectional area, V is the velocity, all those things you have right now with you. Okay, and sigma d you will assume, if not it is provided over here, you can see in the next page it is given here. Sigma d is 2.26. okay, W weight density, I hope you remember what we have done in the belt drive, flat belt. We have assumed the value as 10 into 10 cube. Here it is going to be 10 into 10.89 in 10 cube. Okay, now you have to calculate the value of e to the power of mu theta, but it is mu 1 theta. See, there is a difference between mu theta and mu 1 theta. See, mu theta, mu 1 is what? Mu divided by sin alpha by 2. So please don't get confused. Mu 1 is nothing but mu divided by sin alpha by 2. Alpha is what? The groove angle. This angle is called as the groove angle. Okay, which is given in the table number 14.16. okay, 14.16 what? Let us go and see what is given in the table number 14.16. It is given in 14.16. I think I have already explained the table number 14.16. See different values of cross section, different alpha values, 38, 36, 34. Okay, so if we have a special value like 40 given in the question, you have to use that 40 for the calculation here. So mu divided by sin alpha by 2. If mu is not given in the question, you have to assume that a value of 0.3, 0.4 like that, 0.3, 0.35 like that. Okay, please don't go for a higher value of coefficient of friction. The usual range is 0.25, 0.3, 0.35 like that. Okay, 0.4 etc. So use this equation, and also you have to calculate T1, T2, sigma c, and all those things like what we did for the flat belt. That concludes the design of V belt. Okay, so design is quite simple. In the coming classes I will solve 2-3 questions from the design of V belt. So by that time kindly make a note of the design procedure that I have explained, and kindly refer the data handbook and have a idea about the various set of equations. Okay, and one more thing, see, apart from these equations there are some other equations tables also which is given in the data book. See, one is this table number 14.14, classification of V belt. Okay, so they have given you the different cross sections of the type A, B, C and D. See, for example, if the cross section is A, the nominal top width is what, 13, and nominal thickness is what, 8. All these things, recommended velocity, all these things are also given in the data handbook. So by the end of the design it will be better you draw a figure and mark all these dimensions, because this cross section is what, fixed. You cannot have a cross section of your own, because usually what we are going to choose a belt which is suiting our application. We are going to select a belt only. Okay, so that is the important thing that you have to notice. I think all the other tables we have explained. All the other tables we have explained. There is nothing left with. Okay, so kindly have an idea about the design of V belt. Study well. And in the next video we will discuss 2-3 problems from the design of V belt. Thank you.